SSO is single sign-on, and RubyCAS is its implementation in Ruby. It's all relates to authentication, and every time I go and read something about authentication, there's always a diagram for some reason. There will be square here, there's some server there, and there's like user icon, browser icon, and it never makes sense. It's like art, where if you're a creator and you're an artist, then you do it and everybody else just tries to guess what is the concept. I worked with RubyCAS for about 5 years so far, and I even made my own diagram. I think I did show it to some people. It didn't make sense. So the good news is we're going to go with no diagram. I'll just keep it like this. The only question I have, does anybody feel really good today? Who feels really good? OK, come here. 2, and you, come here. Yeah.
Actually, I missed something before you were good.
What do you have?
It's in the wrong mode.
OK, that's fine. Come here.
There's always something.
OK, you'll be standing on that side. No, you'll be standing there. You're good. And you're there.
Okay.
All right. So what's your name?
Jelani.
Jelani. OK. Now on, your name going to be app1.
App1. There we
Yeah.
go.
You can guess your name.
App2.
App2. That's very good. You didn't get. What do you think your name going to be?
Authentication server.
Yeah, you're going to be single sign-on. All right. So, and I'll be user in a browser. So let's say I want to be eventually logged in all these applications here. So the first thing I do is I go to app1, and what do you think you're going to do? I want to be authenticated in app1.
You're going to say, what's your username and password, or what do you want to create?
Yeah, if you would authenticate by yourself, that's what would you do. You would ask for username and password here. Instead, you don't, and you just send me to single sign-on system.
Okay.
Yeah, wait a second, I need to grab something. It's a very secure thing, and you're going to be in charge of it. Here you go.
Okay, cool.
So you send me to SSO, and that's where I actually authenticate. He asks me for username and password, and if it's correct, you're going to give me a ticket. It's basically like a key, just a set of numbers. And with that ticket, I go back to app1 and saying, here we go, I'm authenticated. But you cannot trust that. I just brought some random number over here. So what you do, by yourself, without me, you go there and check if it's legit. All right, cool. You go back, and now you can trust it. It doesn't matter anymore. You can throw it away. It's one-time thing. You don't need it anymore. And now I'm authenticated here. Now I work in this application, and then I'm going to application number 2. Guess what you're going to do? Send there. Yeah. You already know that I'm authenticated. You keep the cookie. I'm good. You just give me a ticket. Good job. So here we go. Can you trust that?
I don't think so.
Yeah. What are you going to do? And it's not through browser. It's not through me. They have their own connection. They check out if it's legit. Yeah, you can just throw it away.
Cool.
And now I'm authenticated in here. And I stay here as long that session is in here. And if at some point session expires, I go back there, cookie is there, and you just send me back. Any kind of functionality that relates, if you don't enter password properly, all that stuff happens only in one place, and you don't have to re-implement it anywhere else. Thanks, guys. Good, very good job. So RubyCAS is written in Ruby, obviously. We're going to go into boring parts, so you can check my Instagram. It's boring. What happens is it's a Sinatra app. It's basically a web framework. It's really fast. It's a very simple HTML page with username and password, which you can authenticate through, and a little bit of backend, how it all works. And it's pretty easy to set up. It kind of works out of box. Did you ever notice nothing actually works out of box? But you need to configure it a little bit, play with configuration, and then it just runs like any other web application, however you want to write, however you want to run it. What happens is you do need to configure it, connect to your database or whatever, your system where you store username and their encoded passwords. And out of the box, it has several ways how you can authenticate users. This is a set of files it has by default. So if it's some kind of SQL database, it have basically predefined ways of dealing with that. It has Active Directory, LDAP, should be pretty much same thing, Google, OpenID. So it can connect to one of those systems. You just need to play with configuration a little bit. And it will be going there to authenticate user, to check your username and password, and then all that process that we just showed is going to go through all of that. Out of the box, what it can do is not a lot. It obviously can ask you for username and password, let you in, exchange all these keys, and also provide a little bit more information for the application about you. There's a difference between authentication and authorization. Authentication means you can get in, and that's the only thing single sign-on knows about. Can you get in or not? What kind of features you have access to, what kind of rights you have in the application is very different story. But it can help with this because it already has access to your database where your users are and all their features, all of that, and it can send it back to application, so application doesn't have to go again in database and rerun those queries and get this data again and again. So it can help with that. There are clients for a lot of frameworks. There's client for Rails. If you write in Python, there's a client for that. So there are lots of libraries, and even if you use some kind of very exotic application or technology, it's actually not that hard to implement it by yourself. And that's it. Everything else that you typically would expect from it is not in there. For example, one huge problem we ran at the company I work when we first introduced it, there was no forgot password. Who forgets their passwords, right? And if you don't know your password, like you can just call and ask maybe. What happened is we didn't implement it, and because it was switched from traditional application into single sign-on, basically it means it killed all the sessions and everybody was in logged out state. And actually 80% of them couldn't restore their password because functionality is not in there. So they started to call, we had to roll back to the old system, implement I forgot my password, and then put it back. I think there's a reason they want to keep it very simple, and how you implement I forgot my password process can differ from company to company, so they kind of leave it on the side so you can implement it on your own. But that was, we didn't expect how many people cannot memorize their passwords. Another cool thing, sometimes you have enterprise clients who already have single sign-on, and they don't want you to generate some username and passwords for their users because they have a process, they have particular security certifications, and sometimes it's restriction that they don't want anybody have any extra passwords into any other systems. The cool thing, what you can actually implement with single sign-on is to chain those single sign-on. So you go to app 1, it redirects you to SSO, RubyCAS, then from there it can redirect you further to another enterprise single sign-on system of your client, and then it jumps back and jumps back. So there are libraries that are available for Ruby that can do it. For example, OAuth, if you want to authenticate people through Google, log in with Google or log in with Facebook. You can just put, it's Ruby, there are Ruby libraries for that, so you put them in, and then you can implement these kind of things. If you work with enterprise clients, there is a gem for SAML protocol, which also you have to implement from scratch, but there are libraries which make it easier. And you can implement them. It will jump from app 1 to single sign-on as RubyCAS, and then it will jump into some SAML enterprise system and back and back. Out of the box, it has username and password fields, this interface is not actually that pretty. So you probably want to do it on brand and color it appropriately. It's very simple HTML page. You can just edit it manually. It's just something to be aware of. They kind of allow you to go into configuration and change a couple of parameters, like what it says here and there. In the essence, if you want to change colors and whole layout, it's just HTML page, and you can go and just implement it like any other Sinatra or Rails application. One thing that, for some reason, a lot of login systems fail to do properly is redirection. Let's say I already have a bookmark in my application. I want to go to a specific page. I'm not logged in. I'm redirected. And when I'm redirected back, it doesn't properly land me. It just lands me in the main, on the main page, but not the path that was in my bookmark. Sometimes it does work, and they redirect it properly, but only first time. If you enter wrong password, and then you enter right password, it doesn't redirect it properly. And here, we had to implement it from scratch, and it's not that hard to just keep carry on this parameter, which says, what is the URL you want to go back to? It's one of, I think, really good user experience things that if you enter wrong password and then you figure it out or enter right one, it always remembers, and it's very easy to do this. It remembers the path you want to go to, it redirects you back, and on the client side, you'll just catch that parameter and redirect them properly. It's a really cool feature. It's pretty much all backend coding, but it's not that hard to implement, and it's really good for users. They're going to like it for that. Regarding authorization, a lot of heavy work needs to be done on the application side. The only thing it can provide is a couple of records that in the same table where you store username and password, it can grab extra records and send them back. Sometimes it's a little bit more complicated. It's not just that table where you store users. It's a couple of others. Maybe there are some account properties, some features. So you want to make whole requests to grab all that information. You want to authorize users to use particular features or go to specific pages. So for that, you can do a little bit code modification on single sign-on side. Basically, there is a path, and if you use SQL database for authentication, there's a method called getMatchingUser, and you can modify it to go into your database, grab whatever you want, and send it back. And we do it in OpenStruct. OpenStruct is like hash where you can access by dot method or by key or by strings, like universal hash. And you just put all the attributes, let's say from user table, maybe from any other table. You put it in huge hash, and you return it from that function. And that's what SSO uses to send all the information to the application. And once you're in application, then you can get this information and do something with that. For example, in Rails, there is a library called can that basically made for authentication. So it can take that request, and it will work with this, and it will know where a user can or cannot have access. A couple of other useful things you also want to consider is app switcher. SSO knows what application you can have access to. So you can just make an extra page where once you log in, you can present them, hey, this is all applications you can have access to, and you can click on them. As well, you can send that information to the application, and application will know what other software or websites you can have access to. So this way, you can have like drop-down menu with application switchers on your software here or in RubyCAS over here, in both places. It's pretty cool. Nothing too big, but really nice like user experience feature. Another one which is pretty cool is to change temporary password. Let's say when you create an account or a user create their own account, you just assign a password to them. Once they log in for the very first time, you can ask them to change their temporary password. And anything else you can think about, imagine it is just Ruby code. You can go ahead and modify it to your needs. So what happened, there's a file called server RB. It's pretty much all the logic that happens in regards of all the requests, HTML pages, and all those tickets and code exchanges. It's in one huge file. It's 787 lines in a repository. And then we started to do all those modifications, and we even cleaned up code a little bit because we just use MySQL database, and there are lots of other pieces that try to work with other systems. We just cleaned it all out. So with cleaning up, it actually went up to almost 2,000 lines of our custom codes, including like we had to remove a bunch of it. So, but it's Ruby. If you know the language, you can implement a lot of things on your own on top of this very simple mechanism it provides out of the box. Couple of things in regards of security. I mentioned in the beginning it's very important that application makes their own connection to SSO to check if ticket is valid. Because what happens if you give it back to me, a user, a browser to carry on, it goes and who knows what I can do with this. So it is as secure as your connection between your application and single sign-on. Because whatever happens between them, if somebody can modify that, that's the only problem you're going to have. So out of the box, doesn't provide you any extra security as anything else. You have to think how they're going to connect. You obviously want to use SSL because otherwise it can be easily modified. Another thing which is you really need to consider, it doesn't force you to encode anything in your database in any way. So if you store open passwords in your database, it's going to keep working with that. So basically security is still on you. It just works with whatever you have, and it doesn't force you to do something particular. So if you care about storing passwords secure, it has a lot of encoding and decoding libraries already in it, and it's going to work with what you have, but it doesn't enforce you to do this, which is very important to keep in mind. Another thing is cross-domain. What it means is if you have myapplication.com as the main domain, and then for everything else, you say, oh, I'll call it app1.mydomain.com. This is going to be app2. What people do without single sign-on, without true single sign-on, they authenticate and they try to play with cookies and put cookies to parent domain. It's very cumbersome and it's very questionable from security standpoint. So it's kind of first thing you can think about, but then you realize that it's not that easy to implement, and then it's very questionable because there are lots of things that can be done security-wise to intrude into the system. So single sign-on not only avoids that situation, but you can have completely different domains. You can have like app1.com, app2.com. Single sign-on can be on completely different domain. It doesn't matter at all for the system. You don't have to think about cookies. You don't have to think about anything else. You have server here, client here. They interact, and you can use any domains or names you want. It doesn't depend on that at all. In the beginning, when you set it up, there's a config/config YAML where you set up all the initial parameters. So it does store all these tickets and codes in their own database. At the same time, it connects to whatever you store users and passwords. So you just specify this database. You also specify which column you use for username and passwords and extra attributes. It is all those extra parameters, extra fields you want to grab from that table with users to send them back so application can take this data and, for example, use it for authorization. So it's just summary of all the things that you want to consider to implement by yourself. So out of the box, it's a very simple authentication system. It doesn't have anything of that, forgot password, other SSO system, custom login page, how you control redirection, Accept license, that's another thing pretty popular, or change your temporarily password and app switcher, all those things you really can implement in your own way, and it's a natural application, it's pretty easy framework. As long as you don't go in any complications and you don't feel like, okay, that's the place to use Rails or something more sophisticated, it's actually a really good platform to write a little bit of Ruby code and do very good user experience. So, for those who are going to ask really cool questions, I'll give you a card with personal message. Who wants to ask a question?
Is that project maintained currently?
Sorry?
Is the project currently maintained?
Yeah, I'll give you a card. It's, I think, a couple of years ago. Here you go, your prize. It's very simple. I think it is maintained, but I didn't see any commits for a while. And I don't really know what those commits would be for. I don't think there are lots of open issues, like not crazy. Like people want just some super feature or something. Maybe you can consider, oh, I want this forgot password to be implemented. Like things like this exist, and they're like, no, we're not going to do this. Overall, it's very simple, and whatever isn't there is not a really big project to have a lot of contribution. So I think it is maintained, but rarely. Not too often. I have more. Maybe 48 at this point. Oh, it's Queen of Hearts. It's a good one. Here we go.
How would you compare this approach to just creating a server that issues like JWTs and have that authenticated, via the public key on the other side for the other services?
Can you repeat that?
Like, how would you compare this to just creating a small service that issues JWTs, which is a fairly popular solution nowadays that can be verified with a public key?
So the question is, why don't you just go implement your solution, for example, use JWT, which is very, very popular, and make it on your own? The answer is yes, but you just have to create something from scratch where that already works. And CAS is actually standard that not only implemented by RubyCAS, so it's already implemented by multiple other systems. So the answer, you can always implement your own solution from scratch. It just doesn't make a lot of sense to do it. Or you can, as an alternative, actually, you can use some enterprise system like Okta or some SAML, which actually very hard to set up. And usually you cannot go and just modify code and do whatever you want. You have to go through a very cumbersome process of adjusting configs, maybe dealing with XMLs to adjust everything. So the great feature about this is the Ruby code you can modify by yourself instead of dealing with something like creating from scratch or using some huge enterprise system, which might be overkill if you're working on a couple of simple applications. So it has very specific niche. $47 left. We're going to stay here for a long time. I need to use all of them. Here we go.
I was kind of curious if you essentially had any sort of complex exploration scheme for the various services that were using the centralized SSO.
Can you give an example?
Well, just like certain services are a little bit more sensitive and like say they handle a financial transaction when the other thing is, like a personal.
Okay. So
one needs to expire a lot quicker.
yeah, so the question is about, I guess, just following particular guidelines or certification or standards, how long you store cookies, how, let's say, users and passwords stored and encrypted, things like this, because in some industries like healthcare and finances, there are strict requirements. So some of these things adjustable through config, like lifetime of cookies, and some of them, because it's Ruby code, you can implement, and some of them comes down how do you encode passwords, which everything security-wise pretty much falls on actual engineers who are going to implement it and how your whole structure works. This is just a bunch of code that works on top of your solution. It's not more or less secure than what you have. So it's pretty much you have to figure out on your own. You can adjust a couple of parameters in the config And then if it's something more than it can handle, you can just go in a code and actually implement by yourself.
Follow-up, say that.
Yeah, go ahead. I can give you another one. I have a lot of them.
Does it also have the notion of like a refresh token that it can deliver as well, so that it doesn't, so the person doesn't have to re-authenticate necessarily. The service can say, oh yeah, you're still fresh.
There is a lifetime of different cookies and tickets. Those tickets, they exchange. So what happens is you can set up lifetime for all of them as well as lifetime for cookies. It's all adjustable. There are some defaults. Usually on RubyCAS side, you want to keep it longer. And on application side, you want to keep it shorter. And in case your session expired, you can quickly go through a whole loop. And it actually goes so fast that in a browser, you don't even notice that it went back and forth. You don't even see how it changes. Like, because it's so simple, it's so fast. So usually the guideline, you want to keep it short on the application side, especially from time to time, something changes, like what you can have access to. So you want application to expire cookies faster than single sign-on. But it has defaults, and basically the analogy is something similar to refresh token and auth is there's no really token. If your session expired and you want to authenticate user again, you just go to single sign-on like a regular request, and then it goes back with these codes and tickets and just goes through the whole loop. So you don't need special token to refresh authentication. You just redirect user back and forth, exchange those tickets, and there's no any special ticket to do this. So it's actually a little bit simpler than OAuth, like a little step closer to simplicity. Go ahead.
Do you need a client on the app side to receive and validate the tokens, or are you just hitting an API with a regular
Okay.
URL request library?
So the question is, if you need, on a client side, do you need some special library, or you can just hit APIs? Thank you. It's a little hard. In between clubs, I thought it's a cool idea. So you do need library. Even if you don't have it, it's not hard to implement, but it's not just hitting APIs. There are a bunch of things that it does out of the box. For example, I'll be talking from Rails perspective, the Rails RubyCAS client. You just need to tell it what's the URL of your single sign-on, and that's the only thing it actually needs to know. So all those cookies, storing authentication information, exchanging API requests and tickets, and even some help with redirection to where a user wanted to go initially, it's all already implemented in a library. So they do exist. It's not hard to implement them if you use some exotic technology. At the same time, I know PHP, Python, and Ruby, they all have clients. They just handle a lot of things that very simple and should have been done anyway. So it usually doesn't make sense to make your own solution. You can just use library and just adjust it. So on the client side, you might want to implement some modifications. And from my experience in the Ruby library, it's actually really easy to do. You just go into client code, see what the function where a particular thing happens, and you can just inherit from that class and implement your own function to do something a little bit different. It's a good one. Go ahead.
Are we talking about the RubyCAS server GitHub repo or a different one?
Sorry?
Like Dave and I were just looking at the GitHub, and the gem spec says that Rails is less than 4.0. Well, that's a very old release that has known security vulnerabilities. So I didn't know if we were looking at the right repo. But that would, if that were the case, I would not be using that in production.
So because we deal a lot with this server.rb, where basically you can make all the modifications. If it doesn't work, I didn't check it, what Ruby version doesn't work, but from my perspective, the code is very simple, and usually Ruby is backwards compatible. So there's nothing.
To update, but the official repo looks
I think official repo might depend on something old, and they eventually drop support of that, and it kind of ties up to a question about how well it's updated. But I think we use version well above the one that it went with, and it just still works. And the code there is so simple. There's nothing exotic happens Ruby-wise that somehow fresh version would not be able to support. And even if it is, it's not actually a complicated file to go and modify it by yourself. Definitely, I don't know up to what version of Ruby it works, but definitely well above the one that they used to implement it. It's a good one.
Yeah, it was pretty old. Without support, so.
Yeah. Awesome. Well, thanks, guys.